Bismillahirrahmanirrahim. How are you, students? Today we will study unit number 2. Chapter name is kinematics, and today topic is numerical. A train moves with a uniform velocity of 36 km per hour. So first we will convert this 36 km per hour into meter per second. First I will convert 36 km per hour into meter per second. So when 36 velocity is 36 km per hour. So 36 is multiplied with 1000 and divided by 3600. So it will be equal to 10 meter per second. So here this will be equal to 10 meter per second. Find the distance using this formula. You will find the distance. It is 100 meter per second. Now next numerical, a train starts from rest. It moves through 1 kilometer in 100 seconds. So 1 kilometer in 100 seconds. I will write the data. Train start from rest. We will write data. Time is equal to 100 seconds and distance is equal to 1000 meter. Kilo means 1000. What will be speed at the end of 100 meter 100 seconds? At the end of 100 seconds. So V is equal to S is equal to VIT plus half AT square. Use this equation, you can find the distance. If there is any mistake, you can WhatsApp me. Distance is given, initial velocity is 0, time is given, acceleration is not given, so we have to find the acceleration also, and time is also given. So first we will find acceleration. The train starts from rest, it moves 1 kilometer in 100 seconds with uniform acceleration. What will be its speed at the end of 100 seconds? So the best option for you is that you use this equation. With this equation, you find the acceleration. Because distance is given, vi is given, so you will find not you will not find this distance. You will find acceleration by this equation. When you get the value of acceleration, you will use first equation of motion for the final velocity. V is equal to vi plus at. So use this equation. S is 100 meter, 1000 meter. You will write 1000 in place of distance. You will write 1000. Vi is 0, so this whole term will become 0. Time is given, so 1000 in place. You will write in place of distance. You will write 1000. This term will become 0 because initial velocity is 0, so it will make the time also 0. Plus 1 divided by 2. In place of acceleration, you will write a, and in place of time, you will write 100 second whole square. So here acceleration is equal to this 2 is multiplied with 1000, it will become 2000 divided by 100 2 times, divided by 2 times 100. So divided by 2 time 100, we will get 0.2. So acceleration is 0.2. Then by using this equation, you can find the final velocity. Initial velocity is given. Acceleration we have already find it, and time is also given. You can find it. Now a car has a velocity of 10 meters per second. car has a velocity of 10 meters per second. So initial velocity is, we will write data. Initial velocity is 10 meters per second. This is the initial velocity. It accelerated 0.2. Acceleration is equal to 0.2 meter per second square per half minute. Time is equal to 30 seconds. Time is equal to per half minute. Find the distance traveled during this time. Find the distance traveled during this time. We have to find the distance and the final velocity also. And the final velocity also. So first we have to find distance. So best to me the best option is the second equation of motion. F is equal to vi plus vit plus half at square. So distance will be equal to vi is 10 multiplied by 30. Acceleration is 0.1 divided by 2 multiplied by 0.2 and multiplied by time is 30 seconds. So here we will get 300 plus we will get 90 times square. So 390 is the answer. Now find the distance traveled and the final velocity. So we have initial velocity, acceleration, time, distance. So we can apply, we will check the equation, which equation we can apply. So first we will check the first equation of motion. F is equal to vi plus at. So vi is 10 meter per second plus acceleration is 0.2 multiplied by 30. So we will get 16 meter per second. 16 meter per second. Now, a tennis ball is hit vertically upward. A tennis ball is hit vertically upward. Is vertically upward. Tennis ball is hit. I will write the data with the diagram. You will write it separately. Hit vertically upward with a velocity of 30 meters per second. So initial velocity is 30 meters per second. It takes 3 seconds to reach the highest point. How much time it will take? 3 seconds it will take to reach the highest point. The value of g, gravitational acceleration, is 9.8, but for simplicity we take 10 meters per second square. Calculate the maximum height reached. We have to find the height. How long it will take to return to the ground. So remember that time for upward motion is t1 and for downward motion is t2. So time for upward motion is equal to time for downward motion. So time will be 3 seconds. For downward motion, the time is also 3 seconds. If it takes 3 seconds to reach the highest point, the same time it will take to return to the ground. To return to the ground. So time is equal to t1 plus t2. So it's 6 seconds. It is 3 seconds. It is also 3 seconds. And it will take 6 seconds to reach the highest point. It will take time of flight is 6 seconds. How long it will take to return to the ground? So the time of flight, it means time of flight. So time of flight is 6 seconds. Calculate the maximum height reached by the ball. So for this we will use third equation of motion. 2gh is equal to v square minus vi square. So initial final velocity will be 0. When a body is thrown upward, its final velocity is 0. So 0 square minus 30 meter per second whole square and 2 multiplied by minus 10 and h. Simplify this equation, you will get the value of height, and height is, you will get height equal to 45 meter, equal to 45 meter. From this you will get minus 900. So minus 900 divided by minus 20, you will get 45. Now, a car moves with uniform velocity of 40 meter per second for 5 seconds. Velocity is uniform. Velocity is uniform. So, data. Velocity is uniform is 40 meter per second for 5 seconds. Time is equal to 5 seconds. So, S is equal to Vt. 40 multiplied by 5 is equal to 200 meter. It comes to rest in the next 10 seconds. So this velocity, in this case, it's uniform. So this will be the data. So when for this you will change the data. This is the second case. It comes to rest in the next 10 seconds. So the velocity will become initial, and time will become, for the second case, the time will be 10 seconds. The time will be 10 seconds. Find the deceleration. Find the deceleration in the total distance traveled by the car. So find the deceleration in the next 10 seconds with uniform deceleration. It comes to rest. So final velocity is 0. Final velocity is 0. So first we will find acceleration. 2as is equal to v square minus vi square is also right, but we don't have the distance and acceleration, so we cannot use the third equation. Best option is use first equation of motion. V is equal to vi plus at. Acceleration is equal to v minus vi divided by t. So acceleration is equal to v is 0 minus vi is 40 divided by 10. So it's 0.4 minus 0.4 meter per second square. I didn't write the unit, but you write the unit. And now you can use third equation of motion to find the distance. 2as is equal to v square minus vi square. So v is here 0 and vi is here 40 meter per second. Acceleration we already find, it is minus 4 meter per second square. So write the values and do it, solve it. Now comes towards the next numerical. A train starts from rest with an acceleration of 0.5 meter per second. So initial velocity is 0 meter per second with an acceleration of this one. Acceleration is 0.5 meter per second square. Find its speed in kilometer per hour. Final velocity, we have to find it in kilometer per hour. When it has moved through distance of 100 meter, distance is equal to 100 meter. So we have to find the final velocity, and we have to find the final velocity in kilometer per hour. So third equation of motion is suitable to me. Might be I'm not right. I can also make a mistake, but you can make calculation. Distance is given, acceleration is given, final velocity, initial velocity is given, so we can find the final velocity. So 2, acceleration is 0.5, distance is 100, and v is, we have to find, and initial velocity is 0 whole square. So 2 5s are 10, it's 100 is equal to v square, taking square root of both. So vf is equal to 10 meter per second. Now we have to convert this 10 meter per second into kilometer per hour. So 10 multiplied by 3600 divided by 1000 meter. So divide by 1000 and multiplied by 3600. So you will get 36 kilometer per hour. So students, today we done the first numerical, the second, the third, fourth, and the fifth, and the sixth one. In next session, we will your syllabus will be completed. If you have any query, you may ask. WhatsApp me your question. I will answer your question. If there is anything lifted, you can WhatsApp me. I will do it in the next coming lecture. Thank you, students.